Hello, everyone. Good afternoon. So we welcome to this brand new eighth webinar about turning ideas into reality with physics simulations. So meanwhile, we are waiting for others to join, and we will wait for another 5 minutes. So do inform your team members who have not joined the webinar yet. This webinar will be important for the teams who are going to implement the simulation part in their product design. And as you have already received your licenses, simulation licenses so far, so it's time to better utilize it. And through this webinar, our experts will take you through how you can implement the basic simulations as far as your product design is concerned. So we will wait for another 5 minutes, and after that, we will start with the webinar. Thank you so much. All right, so let's start. Hello and good afternoon from India, and welcome everyone to this brand new webinar, which is Turning Ideas into Reality with Physics Simulations. It's a brand new webinar focusing mainly on the simulation part of your product design. Those teams who are still looking forward that how they can optimize and simulate their designs, what they have created so far, and what kind of simulations that they are looking to do. All of your queries, all of your doubts are going to get cleared in this particular webinar. Today we have our two experts, simulation experts in two different softwares. One is Mr. Devaditya Chakrabarti. He is an industry process consultant from Dassault Systems, mainly primarily expertise in 3D experience, Simulia, CFD simulations, and etc. And next we have Mr. Rahul Rai. You are already aware about him. He has already delivered one or two webinars related to SolidWorks design. And now he comes back again to deliver a webinar on simulations using SolidWorks tool. So they will be taking their turns one by one. So first of all, I would like to welcome Mr. Rahul Rai to share their knowledge about simulations using SolidWorks, and post that Mr. Devadatta is going to give their knowledge expertise. So I hand over to you, Mr. Rahul, now. You can share your screen.
Thank you, Shivam, and hello everyone. So I will just share my screen. Yes, so today I will be giving a demo of SolidWorks simulation. And in this SolidWorks simulation demo, I will be talking about a case study of 3D printed wheel. While preparing this demonstration, I was thinking that this is a product design competition. So how SolidWorks simulation can play a role for those who are participating in this competition. So first, let's understand why to use simulation in a design competition. So first thing is that it will validate design before any prototyping, so that before making anything tangible that you are going to, before manufacture something, you can validate your design virtually, that whatever functionality or whatever the specifications of your product are, they are met in a virtual environment. So because you are validating your product virtually, it will save you cost and time. Before, if you're because if you are going to manufacture something, it will take a lot of time. You need to communicate with the manufacturer, or if you are doing it by yourself, then you need to gather all the material and then do it. And to gather that material, you need to spend money. So it will also save you cost and your time. And because you have validated it virtually, and if your product fails virtually, there is no harm. Because if you are trying to test your, suppose you are creating something which will bear some load. If you are going to put something, suppose like a structure or a base, and if it fails in real life, it can harm you or somebody who is going to perform that test if it is not done correctly. So doing it virtually may gives you safety, and it makes sure that when you are going to manufacture it, it will work. At least it will not fail abruptly. And the fourth thing is that you can optimize your material usage, because validating it virtually, you can perform many what if scenarios. You can increase the material, you can decrease the material, you can test various configurations. So when you are doing all of this virtually, you are wasting zero material, because there is no real material used. You can test infinite possibilities. So that's how you can optimize your material usage. So this skill of simulation is an essential skill for any modern product designers. So let's get started with this. So our case study will be of 3D printed wheel. And so one of the common material used for 3D printing is PLA. and its yield strength is 55 megapascal. So this is the key thing which we need to verify our design virtually. That when we are going to apply a load virtually on our 3D printed wheel, we will make sure that it does not exceed 55 megapascals. Because after, if you, most of you must know that yield strength means after this stress, the product will fail and it will start to deform permanently. So we need to keep any stress induced in our virtual design should be less than 55 megapascals. And so in simulation, we are going to simulate the real world, but we will try to simplify it as much as possible so that there, because if you are going to simulate everything, like each molecule, then the computational cost will be exponential. So we are not going too deep. So our only working condition is that we are going to apply 60 kg load vertically downward. But in reality, there will be, real factors. So there will be jerks, there will be some other loads from other directions. So we are not considering those yet. For initial concept, we are just considering that we are going to apply a maximum load of 60 kg downward. So, and our goal of our of this simulation is that we will check if the wheel can sustain that 60 kg load or not. And so for initially, we are going to just do a static structural simulation. So this will be our approach. And so, yeah, so before going into the simulation part, we still need to verify two main criteria, that what will be our failing criteria. So as I mentioned that the yield strength will be 55 megapascal, but because this is going to be a 3D printed wheel, there are other factors that comes into play, that we are going to print it in layers. So because of those things, there will be, so product may fail before 55 megapascals. So we are taking a factor of safety of 5, because 3D printed wheel and a solid wheel of PLA, they will have different mechanical properties. So that's why we are taking this into consideration. So if we take factor of safety of 5, then the maximum stress in a wheel should be 11 megapascal. So this is our upper limit of the stress that we need to keep an eye on. And so we are not going to use only one wheel. So in this case, we are going to use four wheels. So that means this 60 kg will be distributed onto the four wheels, which will become 15 kg per wheel. And when we are going to use this 15 kg in SolidWorks simulation, instead of kilograms, we are going to apply a force. So it will be in newtons. So it will be 15 into G. So I am taking G as approximately 10 instead of 9.8. So then it becomes almost 150 Newton. So these things we need to understand, that we cannot simulate everything which is happening in the real world into our SolidWorks simulation, because it can increase the computational cost too much. Maybe, if you are going to simulate everything, then while your simulation ends, the competition may end, before that. So we need to simplify things. So this is where your critical thinking comes in, that what are the key criteria that we need to understand, and accordingly we will set our goals, we will set our boundary conditions, and then we will simulate the design. So finally, it all comes to that we are not going to simulate this whole assembly. We will just simulate load on this wheel, that we are going to apply a 150 Newton force at the bore, and we will fix the bottom part. Because so for a static analysis, if we are not going to fix the bottom part, if there is just one force of 150 Newton, so you know that if there is no opposing force, then it will float in a space and accelerate infinitely. So we are going to fix this bottom part, so that, because even in a practical life, when you put a wheel, the bottom part is going to deform a little bit, and it will stick to the your ground. So that's how we are going to simulate the real life scenario of a wheel into a SolidWorks simulation. So let's see how we can do this in SolidWorks. So this is our assembly. So as I mentioned that we are not going to simulate this whole assembly. We will just take one wheel and we will just open this. So now this is our wheel. Okay. And so still there are too many things which are unnecessary for simulation parts, just like these threads and these, these engravings. So these things we can remove because for simulation, these are not that important because the stress generated at these points are not going to affect the performance of this wheel. So we will just suppress these. So this is our simplified geometry that we can use, and the stress generated in this part will also give us some idea how our wheel is going to perform in real life. So first step is here that any unnecessary decoration that you have done on your part, you need to simplify those. And then, yeah, so now you need to activate the SolidWorks simulation plugin. So for that, you go to this options menu, and from there, click on add-ins. And here you will have SolidWorks simulation plugin. So when you click this, it will activate in your present session. But if you want SolidWorks simulation to be active every time, then you can just activate this option also, that it will always activate when you start up the SolidWorks. So when you click OK, you will see a new tab within a second. So you can see this simulation tab. So here, so from the simulation tab, now you need to go to click on new study. And here are a lot of options like thermal, buckling, fatigue, non-linear. So first start with just simple simulations like static simulation. And when you, move forward in your design journey, you can perform other simulations also for buckling, fatigue, non-linear, and drop test and others. So we will, for this webinar, I will just do a simple static study of wheel. So click OK and it will create a new tab of static study of wheel. So your 3D modeling tab is this model and your simulation tab is static study of wheel. Now we need to apply material to this wheel. As I mentioned that we will use PLA material. So just go here to this your 3D model, right click on it, and there is option for apply or edit material. So PLA, here you can see that PLA material is here, but generally the PLA material is not available in SolidWorks simulation, SolidWorks material library. So I will just delete this and show you how you can create a new material in SolidWorks simulation. So just create a custom library, or let's create a library in this. So I will create a new library and name it as 3D materials. So this library is there, and again a new library for plastics. Okay, sorry, a new category. We will create a new category and we will name it as plastics. And in this one, now we will create a new material. So we will name it as PLA. And from the website or the from where you are buying the PLA material, from there you can get these properties. So the property for PLA is its elastic modulus is 3500 and its Poisson's ratio is 0.36 and its mass density will be 1250 and its yield strength is going to be 55 and its tensile strength is 60. So these red fields, those you must fill to perform any SolidWorks simulation, otherwise it will show you an error. These blue ones, these are optional. So you make sure that you have all these four properties before applying the material. So now you have created the material and just click on apply. And now you can see that this PLA material is applied on your part. So now after applying the part, now as I shown that we are going to fix this bottom part, but right now, so I will show you like how you can fix something. So this you need to go to this fixture option, right click on it, and there is an option for fixed geometry. So from this animation, this example animation, you can see like how this fixed geometry is going to, behave. Now there are other options for roller slider, and there is one for fixed hinge. But for now, we will use only the fixed geometry. And now I need to select a face. So right now it is fixing this complete outer surface of this wheel. But we do not want that. We want to just constrain the bottom part. So now we need to split this outer surface so that we can apply different boundary condition to a particular part. Okay, so for that we need to again go back to the model. I will simply just create a sketch. I will make this as a construction line, and I will add dimensions to these lines. So now I will use these two lines to split the surface. So go to the insert, from curve, select split line. This sketch is selected. If not, you can select it from this flyout menu. And then for the surfaces, I will select this outer surface and now click OK. So now you can see there are two partitions of the surface, this smaller one and this bigger one. And now if we go to that static study of wheel, go to the fixture option, select fixed geometry, and now select this bottom portion only. So you can see these symbols demonstrate that this part is constrained. So now click OK. So now we have fixed the wheel, the bottom part of the wheel. Now we need to apply load to this board. So now we will use this external load options from there. So for there are force, torque, pressures, gravity, but for bearing loads, like because here we are going to insert a metal pin or some other way we are going to attach it to the robot. So bearing load is the perfect one for this condition. According to your application, your product, it will differ. So for this one, we need to apply this one. But to apply the bearing load, first we need to create a coordinate system. As you can see, like there is an option to select a coordinate system. So we will quickly create that. Go to the feature option. From the reference menu, select coordinate systems. And for the origin, we will select the part origin. And XYZ, we will keep it as default one. Just click OK to create the coordinate system. Now we can quickly apply the bearing load. So for the surfaces, we will select this hole. And for coordinate system, we will select the coordinate system. And now we will apply the load in the y direction. So it will be 150 Newton. Let's click on the reverse direction. And now click OK. So the difference between this bearing load and normal force is that in bearing load, it will have a sinusoidal distribution, which which is more close to the real application. So now we have applied a load, we have applied a boundary condition by fixing the bottom part, and we have also applied the material. So now comes the meshing. So this mesh option, right click on it and just click on create mesh. So we will use the like the default setting right now and just click OK. I'm using default setting because so that we can, I can show you live how it will create the mesh, and we are going to solve it live also. So by using the default setting, it can be done quickly. So as you can see that the mesh is kind of refined at these joints. So we are going to use this mesh only. So suppose if you want to refine your mesh in a particular area. So for that, there are many options. There are mesh controls. So you can use those to create mesh at a particular, area. So that I will share a learning path for SolidWorks simulation. There you can learn that in depth. But for now, I think this mesh is quite fine. So now let's run this study. So after applying load, so first what we did, we applied the material, then we add boundary condition or fixtures, then we applied some load, then we meshed it. Now we can run the study. So when you click on run this study, it will take some time and then it will start solving it. So if your mesh is too refined, it can take longer time. So simulation it is not just you do it once. You need to do it iteratively to understand how your model is performing. So let's see. So in the result section, we have stress, displacement, and strain. You can also, get plots for other values. But for now, let just focus on stress. So if we see the value is, so from this legend, we can see that the maximum value is, it is in Newton per meter square. So let's change it to megapascals. So right click on this and you can go to edit definition. And right now it is showing the deformed shape. Let's uncheck that. And instead of Newton per meter square, we will look at it Newton per mm square. So which is megapascals. And from the chart option, we can select to show the maximum value. And now let's click OK. So here we can see that the maximum stress is almost 14.6 megapascals. And it is near this fillet section. So, and we want it to be less than 11 megapascal. So clearly 14 is more than 11. So now we will do some design changes in this wheel, in this model tab, and then we will run the study again to see that whatever design changes we are doing, are they reducing the stress or not. So we saw that the fillet section, the maximum stress was in the fillet section. So just click on the stress and then you can see. So first, let's try to increase the fillet radius. So that stress concentration factor is removed. So we will make it 1.5 or let's just say 2. Okay, so 1.5, okay. And also let's increase the width of this spoke from 3 to 4. We will rebuild this model. And now we just need to go to the static study and we can just run it again. It will remesh the model and then run the simulation study again, and it will give us new results. So earlier it created the mesh and now the results. So now the maximum stress is 8. So which is less than 11. So this model now with these changes, now the maximum stress in the fillets is around 8 megapascals, which is less than 11. So this is safe. So now we can 3D print it and we can see how it is going to perform. And so this is how you validate your product virtually. So this is the simple demonstration, and so like this is the first iteration. You can all so one of the method what I use, that I increase the fillet diameter. Other methods you can use, that you can increase the number of spokes, you can increase the width or thickness of these spokes, you can increase the diameter of the rim. So by testing all of these variations, you can find out like what design changes you need to do to make your product more stable or make it more lasting. So that was all from my side, and so I will just quickly share the link to the SolidWorks simulation learning path, which all of you can go through to understand about SolidWorks simulation in depth.
All
So,
right. Thank you so much, Rahul. That was a very interesting session on how you have showcased the demo of a wheel and how they can actually think of even 3D printing it. I mean, by simulating and then going for the 3D print. Over to you now, Debaditya. All the best.
Uh, Hello, everyone. And what a great day to have a session on physics simulations. The sun is out after a long time here in Pune. So, yeah, so let's take this opportunity and move it forward with ModSim. So, Rahul gave you a really good introduction of physics simulations on SolidWorks. But if you want to be a power user, if you want to get to the real nitty-gritty of physics simulations and get real world correlations, if you want to go into ModSim data science, data-driven physics simulations, then ModSim is the route to take. So I'll start by sharing my screen. I hope my screen is visible.
Yes, they were.
All right, so let's get started. Okay, so let's start by discussing what is ModSim. So ModSim unifies modeling and simulation on a common data model within a single user experience on 3D Experience platform. ModSim is more than simulation-driven design. ModSim actually enables simulation to drive the entire product development process from the beginning to the end, from requirements to architecture, from validation to certification, and from product development to program management, including design exploration, processes, automation, change management, and of course, collaboration. Modson is the answer to juggling between multiple data and functional files from different software environments. Let's consider a common scenario in research and development. A CAD model is imported into a simulation environment. First, the CAD is defeatured. Then it is exported to a pre-processing or a meshing environment. Next, it's exported again for solving. And finally, post-processing takes place in yet another environment. Engineers find themselves juggling multiple file formats, switching between different environments and facing potential confusion if files aren't meticulously organized. But what if we could eliminate these inefficiencies? Today, let's bid a goodbye to these challenges and embrace a seamless end-to-end digital solution by harnessing the power of Modsim on the 3D Experience platform. All in all, 3D Experience platform can help in eliminating all the non-value added tasks like file storage, file transfers, compatibility tests, and rather helps you focus on the more important parts of the design process. Now let's get a simple introduction to finite element method. In all disciplines of science and engineering, the focus is on determining what will happen when a physical system of interest, like a building, a bridge, or an aircraft, even to maybe collection of molecules, or even a living organism is subjected to effects of the environment, which may turn lead to a response from the system, or maybe in special cases, maybe physical processes of systems of matter, or let's say the changes that happen into a piece of matter, what we isolate. For example, due to maybe interaction of that piece with its surroundings, or any physical process that can be described mathematically, in the sense that we can formulate a set of mathematical expressions describing the process and allowing us to determine how the process takes place in space and time. So FEA works by dividing the object into smaller, simpler pieces called shape, depending on the object's geometry. So finite element is basically dividing a big part into smaller chunks. So these elements can be triangles, these can be squares, or any other shape depending on the object's geometry. By breaking down the complex object into smaller pieces, it becomes easier to analyze the behavior of each piece and how they interact with each other. Now, here's the fun part. All of you engineers need not worry about all the fancy mathematics. So sit back, relax, and let the industry leading abacus solvers take care of it. Rather, what you shall focus on is finding ways to optimize your design and elevate the level of performance of product with industry leading CAD and simulation solutions within the 3D experience platform. Okay, now to understand the behavior of metallic components under load, let's understand the concept of a metal that is under load. So here you can see a spring. So you see when the spring is pulled within the yield point, the stress and the strain return to zero as the spring takes back its original shape when the load is released from the ends. When the load is continuously applied, like so, between the stresses and strain, it stops being linear and the load is released from the end of the strain and remains constant while the stress becomes zero. So this is what Rahul discussed earlier. This is what's called plasticity. So you apply the load, and after a certain point, the spring doesn't actually return to its original shape. So these are called plastic deformations. Okay. So now let us review a very basic ModSim workflow. So we'll dive into the 3D Experience platform's native app of CATIA part design. Shubham, is there a way you can stop the interactions right now? Because I'm constantly getting messages of hands being raised. So I'm getting a pop-up on my screen. Is there a way
E-
you can stop that?
For hands being raised, no, Deba, I think it will be coming automatically.
Okay,
Yeah.
okay. Okay, so I think most of you would be familiar with the 3D Experience platform if you have attended all the webinars by now. So let's get started with a simple sketch. So we'll simulate a basic cantilever beam here. So I'll select a plane and start sketching. So I'll make a centered rectangle like so, maybe 100 by 100. Okay. So now we have some new functionalities that you can see. You can either constrain it yourself, like so. And I can see that my sketch is not fully defined, and I can be lazy and just let AI handle it for me. So generative constraints. So as you can see, it in a snap of a finger, you can convert your sketch into a fully defined state. And I can use these constraints as parameters if I want to go for maybe a design of experiments that we'll discuss later. So as Rahul mentioned earlier, that any design process is iterative. So if you want to automate the iterative design process with predefined algorithms, there is an option on the 3D Experience platform now within Physics Results Explorer where you can, set up experiments, design of experiments with classical processes like Latin hypercube methods for varying your variables, or maybe you can even go for machine learning based methods. We can, discuss them later. But for now, let's keep it simple. And I'll go and I'll exit the app and start giving out the formula or maybe the parameters. So here I'll start by first creating a parameter. So from the action bar, I go to the tools tab and I click on formula. And I'll click on plus, double click, I'll change the name. So I'll just keep it length for now. And since I don't want to snap it back to 0 I'll just put 100 so that I can define, or maybe I can, give the details of this parameter to the constraints that we defined earlier. Okay, so I click OK. Okay, so similarly, I can create another parameter called breadth. Breadth again. Okay, so now at this point, what I'll do is I'll click on formula again, and now I'll assign these parameters to the constraints that we created. Okay, I just clicked on the sketch, and you'll see that all the constraints popped up. So I'll click on one of these constraints, the length. Now I'll put on the clicked on the three dots to edit the formula, and from the feature tree, I'll expand parameters. I'll double click. Okay. So I see we have one relation that has been created. Similarly, I'll do the same for breadth. Three dots, edit formula, breadth, double click. Okay. So now if I go back into the sketch, you will see f of x kind of a symbol right next to the constraint. That means these constraints have relations that can be manipulated right from the feature tree. Okay, so now let's extrude this or pad this, maybe 1000 looks fine. Okay, so now I'll change the parameters and check if the parameters are working. Looks like they are. So we're good to go for this simulation. Now at this point, you need to determine what kind of simulation you want to do. So in 3D Experience platform, the best part is you can access all the features of Abacus, that is an industry-leading FEA software, and it is being used by all the top companies of aerospace and defense, in transportation and mobility sectors, high tech, and you get all the features of Abacus, which is mostly a developer-focused FEA software, into a very user-friendly GUI here on the 3D Experience platform, and you get the same results you'll get on Abacus CAE right here with a much friendlier user interface. So I'll just name it cantilever. I'll put the analysis type as structural. We don't have a finite element model yet, so we can't select anything. And I click on OK. Now, the best part about 3D Experience platform is that you have an assistant. Yes, you also have a simulation wizard on SolidWorks that kind of functions similar to the assistant. So if you just keep following the assistant here, you can be guided through the full setup of your simulation, or the pre-processing as we call in the industry. Okay. First, from the action bar, I'll go to the setup tab here and click on model. Now, as soon as I click on model, I'll get a dialog box saying what kind of a FEM model I want to create. So I'll keep referring finite element model as FEM because that is a jargon that we use in the industry, and it kind of makes it easier for us to say. And for the initialization method, I just put none here because if I just go for automatic, it will give me a tetrahedral mesh. And I have a swept part, something that is continuous and it is also rectangular. So if I want the best correlation with the real world model of a cantilever beam of these dimensions and a certain material that I'm going to use, I have to use the best kind of or the kind of mesh that will yield the best results. And how can you decide it? And how can you decide what kind of mesh you want? For that, you will need to read the Abacus documentation. And yes, again, there are courses on EduSpace that can guide you through how to select the best mesh element for a particular geometry. Okay, so I see a FEM module has been added to my product structure tree. Next, I'll go to the mesh tab, search for the kind of mesh I want. So I want a hex mesh. So either you can go for a sweep 3D mesh or you can go for a hexadominant mesh. So for the support, I'll select this geometry. So now I kind of know what the dimensions of my beam is. So according to it, I can refine the size of mesh. So the smaller the size of your elements are, more will be the time for computation because we are solving partial differential equations here, and partial differential equations do not converge to zero, and it takes a lot of time for them to uh, solve. Okay, so I won't get into the mathematical part of it. I just want all of you beginners to get a flavor of ModSim, of how you can leverage ModSim and basically sweep through your workflows quickly. So maximum size, maybe we can keep 50. Minimum size is 5. I don't think this 5 will influence anything here because it is, uh, it has a square geometry, so it shouldn't be a big deal.
Because we also don't have
Complex contours in our geometry that can influence the size of our mesh or the elements that have been taken. So I see that we have a really coarse mesh here. So you can go ahead and even change the size of the mesh. So maybe if I put 20 here, and I know that the dimensions I took are multiples of 20, so we can get a very nice clean mesh here. Next, so whenever you are working with the simulation, the finite element models of or FE related apps, you need to make sure that you have a basic understanding of how abacus simulations work. That will come in really handy if you want real world correlations. And like in abacus, you need to give it a section property. So here we have a solid section. So I'll just either I can, click on the geometry here, or maybe I can click on the mesh as well. Now I will assign the material. So we have some predefined materials that are standardized. So if I go to DS standard, click on the drop down here and click on DEI steel, click OK. And now we have this drop down that makes us select the behavior of the material. So here we are doing a structural simulation, so we need an elastic plastic behavior. So I click on OK. And as I can see in the assistant that I think we are good to go into the scenario tab now. And the scenario tab is where you'll actually start by defining what kind of procedure you want. So here you can see you have a whole array of procedures. The static step, you can get a little introduction of what actually this step is. So like we did earlier, the static step will actually consider the plastic behavior of the material, and you can also solve it using static perturbation step, which keeps the model linear, so it won't give you plastic deformations. So with static step you can actually calculate for plastic deformations, but static step is computationally more expensive than static perturbation step. Then you also have implicit and explicit dynamics. Implicit dynamics are used for low speed events, kind of like when you do quasi-static analysis of rubber gaskets, or high strain bearing products. Like I mentioned, it can be rubber gaskets or rubber mounts, or something that deforms in all the axes when any force is applied on them. Then we have explicit dynamics that is used for high speed events. So maybe if you want a projectile that is crashing onto a wall, or a crash test of a BIW, of a car chassis, you can simulate using explicit dynamics. And then you have a frequency step that is basically modal analysis. And if you have taken your vibrations class in your fourth year seriously, then definitely you can go for dynamic analysis. And it obviously helps in determining how well you have designed your model for dynamic loads. You can calculate for natural frequencies of your design as well. I mean, that is the main agenda if you are using frequency stuff. Okay. Yeah. So I went with the flow. I see that my procedure is incomplete, so I'll go ahead and select static step. I think the default settings are okay for a basic workflow. So I click on OK. Next, I'll go to boundary conditions. Now here, you can either go for fixed displacement, or you can also go for a clamp. So I want to keep everything simple today. So I'll just use a clamp on the rear face of the cantilever beam. Click on OK. So when I select clamp, it means that all the degrees of freedom have been locked for this face. So now I'll rotate it back again and go to loads. I can again click here on the assistant, and it will give me all the frequently used forces, or the loads. So I'll just put a force here, maybe through the z-axis, 1000 Newton. I see that the direction is not where I want it to be, so I'll put it in the opposite one and click on OK. And I see that the system is saying that we are ready for simulation. So I click on simulate from either here or maybe, oh, so before we hit simulate, I think it's a good opportunity for us to introduce outputs. So if you want, so okay, by default, when you're setting up a simulation based on the loads and on the conditions, there are some standardized output requests that are made ready for you. So it covers the most information that maybe a basic simulation uh, needs, or the basic simulation can output. But if you want to go into the nitty gritty and maybe, I want total plastic strains and a maximum equivalent plastic strain, I can create special output requests and I can rename them to maybe P underscore strain, click on OK. And here you'll see a drop down called output group. So what are field and what are history output? So this is again a very abacus uh, solver based question. So what is a field output request? So think of a field output request as taking a detailed photograph of your entire model or a significant portion of it at specific moments in time. Okay. So specific moment in time is the emphasis of this statement, and it captures the spatial distribution of a variable across a wide area. So this type of output is ideal for visualizing the overall behavior of your model and generating contour plots, vector plots, and animations that show how variables like stress, strain, and displacement are distributed through the geometry. Now, because field output can generate substantial amount of data, it's typically requested at infrequent intervals, such as the end of a step or after a certain number of increments. Requesting field output for every single increment of a large analysis would result in an unwieldy output database. And moving on to history output request. In contrast, a history output is like, how can I describe it? It's like setting up a time lapse of a camera, you know, focused on a few specific points of interest within your model. It records the values of a variable at these discrete locations over the entire duration of the analysis. So this is invaluable for understanding the temporal evolution of quantities at critical locations. So history output is commonly used to generate XY plots, which can illustrate relationships like load versus displacement, stress versus time, or energy history of a component. Since it focuses on a limited number of points, you can afford to request history output at much higher frequency. Even, every increment if necessary without creating excessively large output files. So, okay, so now I created a field output for strains here. Now let's see what we can get out of a history output. So I'll toggle here to history. Now you see that most of the outputs that we have are now became time dependent. So if I, request inertial relief force, which is again, it's not significant for our simulation here. So rather I should take inertial relief equivalent rigid body accelerations. Yes. So now if you have, let's say, a force that is abiding uh, some time frequency, or maybe, if the body is not being affected by a force, or rather than an acceleration of a certain elements within the FE model, then I think these output requests would be invaluable for you all. Okay, so I requested two outputs. I think I should actually name it history sample, random name. And now I'm gonna go ahead and simulate. This shouldn't take a lot of time because again, it's a very simple model. And it's a good time to drop in your questions if you have any.
All right.
So now we get right into uh, Physics Results Explorer. So this is where we'll post process our simulation. So we first get greeted by this dialog box. Now here you'll see a drop down. First step. So in this analysis case, we only have one step, so we need not bother with this. So rather, we should all explore what all contour plots we got. So first, let's go for deformation. So deformation was so less, it didn't actually yield anything. So rather, we should actually go for displacement. So displacement, as you can see, is 0.195. Close the assistant for better view. Next one is stress. And I think the plastic strain that uh, we requested earlier. So again, the deformation, the strains are so less that we don't even get into the realm of plastic deformations. Rather, we should also go to factor of safety, which is way over 2. So the plot looks like this. If it were failing, then definitely you would have gotten a color that would be in this spectrum or this legend, and nothing's actually actively yielding. So yeah, we need not bother this. Since we have such a high factor of safety, I think this gives us a room for reducing the material. And this is where I think is the point where the Moxim loop comes in. So now from this tab, I'll go back to part design. Now, you know what? Let's maybe half this dimension. Same, let's do for breadth, and I will give it the first. And I'll go back here, this scenario. And as you can see, the module has already updated with our new dimensions. But the results aren't. Okay, so let's update this. Yeah. Yeah, so my bad. I opened a different tab. So yeah, I just updated it, and you can see that the model is now updated with the new parameters, or the changed parameters, I should say. And now maybe I'll summon the assistant. And as you can see, we already have the CATIA update logo near the results. So that means that the results are not up to date and we need to solve again.
Okay.
And I think we are still way off from actually getting this beam from getting yielded. But again, you can now notice that the displacement has increased a lot. You can say the same for the von Mises stresses. And we didn't enter the realm of plastic strains for this model. But if I maybe increase the force exponentially, then definitely it's gonna yield. So now you can also go ahead and different contour plots and play the animation like so. And again, the scale has been set to 1, so it is actually deforming exactly like it would in the real life. But again, you can play around with it. And this completes our Watson loop. So we saw that our model has a factor of safety that is way beyond what we require. So we shrunk the model, we changed the dimensions using parameters, and we solved it again with just a few clicks. I didn't have to set up the model again from scratch. So with a few clicks and a few updates, we could get our new model all set up and running. So this is basically the essence of Modson. Now we discussed a structural simulation example. Now let's get into a CFD simulation or a CFD application, and that is also in the same app. So you don't have to jump around in different apps. So let me just close all the tabs that I won't be needing from this point. Okay, so now setting up a CFD simulation takes time, but again, guess what? Tree Experience platform has such easy to understand workflows and such such an easy to understand graphical user interface that you can get up and running with CFD simulations really quickly. Okay, so let us get started with one. So here, as you can see that we have a drone here. Okay, so I'll hide it and a bit of visualization. Yeah, so we have a drone here. So I'll quickly tell you what all we are going to simulate this drone's aerodynamics for, what all KPIs we can use to evaluate the performance of this drone in cruising speed. So now as you can see that even the orientation of this drone can be parameterized. So the angle of attack here can be used as a parameter. So right now it's 0. But if I go to assembly design and change the angle of attack, you can actually calculate for ascent, descent, and cruise. Now just head back to the PPT. Here you can see the basic workflow that we are going to use. We start with fluid scenario creation. We won't be discussing geometry idealization because again, it will take a lot of time and the whole workflow is available in the documentation. So if you want to get deep into it, I'll share a link in the end of the webinar. Then we'll head on to fluid scenario creation, where we'll pre-process the simulation and then we will define the physics domains, we'll apply the boundary conditions, we'll customize the mesh, we'll request measurements, the output requests basically, and we can preview the mesh. Again, this step is optional. And we run the simulation and we post-process in Physics Results Explorer. So the model that will be used in this example basically represents a UAV, uh, simplified to a drone. You can also call it a drone. And you'll evaluate the aerodynamic performance of the drone model at the conceptual design state. Okay. So we're not getting into the full, lattice Boltzmann based simulation. We are only going to use Navier-Stokes based solvers here. And a steady state incompressible fluid flow simulation will be performed to represent the drone flying at a cruising condition. So we'll be first importing a model into 3D Experience platform. We'll be creating an exterior flow fluid domain, okay, that can be also described as an abstraction shape. We'll also be configuring a steady state fluid flow analysis. We'll be defining boundary conditions required for the CFD simulation. We'll be meshing the fluid domain with a hex dominant boundary layer mesh. We'll also be post-processing the results. So the boundary conditions that will be used in this simulation will be a velocity inlet that will be equal to 25 meters per second, a pressure outlet sufficiently downstream of the drone at atmospheric pressure. A steady state procedure will be defined. The Reynolds number is approximately 8 into 10 to the power 5, indicating a turbulent flow. And since the drone and the incoming flow are symmetrical about the XZ plane passing through the center line of the fuselage, we'll use the fuselage is basically the main body of the drone, not the wings, but just this body. This is the fuselage. So the drone and incoming flow are symmetrical about the XZ plane, as you can see here. And passing through the center line of the fuselage, we'll use this information to reduce the size of the computational domain. So we won't be, making the fluid flow through the whole body of the drone. Rather, we can simplify this by only passing the flow from half of this model, and then while we post process, we can duplicate this section to the other side, and basically it will help us reducing our computational cost. So the best part about using CFD in the 3D Experience platform is that you can just follow the assistant steps one by one. Okay, so let's say if I start by clicking on model, the first thing that you see is model setup. So here you see all the drop downs and you can go ahead through the drop down and keep specifying what all you want. So the first thing that the model setup needs is the fluid material. So what kind of fluid you are using to flow over the model. So I'll go to the end session and you can actually see the properties of the material that we are using here. Next step is you're going to define what bodies are being or what geometries are being involved in this simulation. So as you can see, it has already been defined here. Next comes the bounding box. So you can either eyeball it by pulling and pushing these glyphs, or if you have, let's say, some hand calculations ready with you, you can create the bounding box accordingly. Next, you need to give a reference fluid region. So the designer here already gave me a publication of the wetting region that we have. So since the fluid is being flown through only the half model, we only select the leading edge of this wing as the region that will come in contact with the plate flow. And most importantly, we will be able to uh, we'll be able to spoke whatever fluid is flowing over this geometry. And again, we'll discuss it later how. So I'm gonna just select this. We don't have any openings in this model, so we should not bother with this. And again, you can select the refinement of the mesh that you want. I just kept it half of the gauge. Again. So if you want to initialize a simulation here, again, CFD simulation takes a lot of time to converge. So I already have one ready for you all solved. So we'll be using that. But before that, let's learn how you can uh, import a model. So I have one file ready here. So what you can do is either you can drag and drop it here.
We have a 3D external ready.
And you will see this pop up. It already has a location ready for me. So I'll click on OK. Just waiting for the model to import.
Let's wait 2 minutes. If it doesn't load, then we'll proceed ahead. I think there are some connectivity issues that are causing these problems. Shubham, just give me 2 minutes. I'll sort out the issue from my side. I think it's connectivity issue.
Sure, sure, no problem, no problem.
Yeah.
Take your time.
Meanwhile, there are couple of questions in the Q&A section. If you would like to answer,
Yeah,
Devaditya.
sure, sure. Go ahead.
Yes, so Ferris is asking, can 3D experience simulation education role make FSI CFD simulation?
Yes, Taras. Yes, you can do an uncoupled simulation, and I think there will be a poll asking you all if you want to go ahead with a fluid structure interaction based competition in the future. So if you all give a good response, then yes, we can have a session on FSI for sure.
Great, great. And another question is from Dr. Ranjan. So he's asking, our team is working on a smartwatch kind of device. What kind of simulation do we need to undertake, and which app to access?
Okay. So if you are using a smartwatch, then you need to understand what kind of uh, environments your watch will operate in. So if you want, let's say, I don't know, just giving it a wild guess, maybe if you bang your smartwatch onto something, then you will need structural simulation. Okay, so explicit dynamics will be the way to go. If you want to analyze if your PCB inside the watch is generating excess heat or the battery is generating excess heat, then you'll need to do some heat transfer simulations. And if you have, let's say, if you're snap fitting the whole assembly, then you can use implicit dynamics to, uh, analyze if the snaps are fitting properly or not. So again, if you are doing physics simulations, then definitely a research-based workflow or a research-based approach will be the way to go. So you need to understand how your product is operating and what kind of failures it can see in its product life cycle.
Great. Thank you, Devaditya. So another question Dr. Ranjan has posted just now. So he's asking, can we do EMI or EMC simulation?
Okay. Yes. So with 3D Experience Engineer, you will get CST Studio. So if it's anything related to electromagnetics, then definitely you can. You'll get CST Studio connected.
Great. Thank you. I hope it answers your question, Dr. Ranjan. Uh, that Those were all the questions. So, okay. He's saying thank you. Thank you, Devaditya.
Yeah, no problem. Okay, so I think we are back online. Okay, so the product imported will look like this. We already had a physics simulation attached with this model. So I think you can see the contour plot that appeared. Let's not uh, get into the pre-processing. I think we have half an hour more. I'm sorry, not pre-processing, my bad. Into the importing part. Rather, let's get into pre-processing or learn how you can pre-process it easily with the 3D Experience platform. Yes. Is my screen visible now? Kundlik, can you
Yes, yes, it's visible.
Yeah, yeah. Thank you, thank you. Okay, okay. So I think we discussed model setup. Here you'll see a whole host of options. You can go ahead, read the documentation. There is again a little description here about what all sections you may need to use within the fluid domain in order to get the most accurate results. Next step is to define the physics model. So you can click on physics behavior. You should rather go from the first step. You can already come. Okay. So here you can see that we name the step as fluid. We give the viscous regime as turbulent. And now here comes the research part of it. You need to understand what kind of a turbulence model will suit your kind of simulation. So here we are using steady state K omega. And if you have maybe highly compressible kind of situations where maybe you are analyzing a turbocharger or maybe you are working with heat transfers, then realizable K epsilon will suit your simulation. Because we are doing a basic Navier-Stokes based simulation, we are going to go with steady state K omega model rather than so yeah, apart from that you can also if you have some bodies that are being heated, so again Dr. Ranjan, if you are planning to check how maybe a breeze of air cools your smartwatch, you can enable thermal effects. If you have maybe bottlenecks in your fluid domain, you can enable compressible flow. Coupled solver will be enabled when you are doing FSI. And I think gravity and particle modeling is irrelevant right now. But again, you can read about these in the documentation. Next, right from here, you can also select and configure the default settings that you'll have. So the operating pressure, the reference altitude. You don't really need an altitude in this kind of a situation. And then you can go for intensity, viscosity ratio for the turbulence specification. And these values are more or less default. So the turbulence intensity and viscosity ratio and velocity scale, these are all default settings. Then I think another important concept here is to define the walls. So we are giving the walls some slip. You can also enable wall roughness, but again, it depends on your model if you want to enable slip or not. So let's discuss why you will need wall slip. So basically, when you have, let's say, a no slip condition, the fluid is, let's say, flowing through a pipe maybe. The no slip condition dictates that the layer of fluid molecules immediately adjacent to the pipe wall is stationary. So this creates a velocity gradient where the fluid velocity increases as you move away from the wall towards the center of the pipe. This is a default assumption in the vast majority of CFD simulations for macroscopic flows. And if you have wall slip in certain scenarios, this is a no slip assumption kind of breaks down here. The fluid at the wall is not stationary, but instead has finite velocity, also known as slip velocity. This means the fluid effectively slips along the solid boundary. I think the name pretty much sums it all. Now let's go back to the assessment. And manager. I think it's a good time to discuss the output request that you would need. So this is the default output request that you'll get. Again, we are not calculating for electromagnetics. This uh, output request is created automatically, and again, we can go ahead and uncheck these. So the important ones are, of course, turbulence based. So turbulence viscosity ratio or turbulence specific energy dissipation rate. You can also have eddy viscosity, or kinetic energy, and again, this will be uh, default if you are selecting a field output group. And in history output, the important ones would be average area, surface gauge pressure, very sorry, and mass flow average surface total absolute pressure. Then you have area average surface velocity vector, mass flow average surface total gauge pressure. Then you have integrated volume flow rate. You have integrated mass flow rate. So these are the important ones that you want to gauge in this kind of a simulation. If you have heat flow, then go ahead checking the heat flow. So I created a different output request just for the fluid force that would be acting on the model. And I have already pre-solved this model because it might take some time for it to converge. Meanwhile, we can explore the post-processing capabilities or whatever we requested. Let's see what all outputs we got out of the pre-processing that we did earlier. Okay, so let's start with the display group. So velocity. So we have a remove tool selected here. So here, since our drone is not moving, but rather the fluid is moving over it, you can see the velocity comes out to be 0. Let's go to view and put it the way it was. So as you from my lecture, so I didn't went about discussing the sectioning option. So just a right click and click on section. So it will section your bounding box. So section this section it again. We were done at 3. Now let's align to an axis. Yeah, I think this is the right orientation. And here you can, hover your mouse over to check the velocity. So again, this is the 0 increment. So as you move to the last increment, then I actually zoom in and scope for all the values around the model. Next. Shubham, like the results are loading. You can see a pop-up here. So meanwhile, do we have more questions?
No, not any questions.
But
There is
but
one,
So
but
we
it's
have
for us.
yes, and we have a poll regarding the feedback of this session. So let me
yeah,
launch it now. Meanwhile, the results are loading. So to those who are already watching this webinar, you will see a poll on your screen regarding the current session. Do give your feedback, and as Devadatta mentioned about a competition regarding Motsum Mania, if you are interested, do drop your answers in that feedback, and definitely we will be in a position to launch Motsum with a different kind of topic under Akruti. So you must be seeing a poll on your screen. The poll is live for another 10 minutes. Please answer that poll. Deva, your screen is visible.
Yeah, I'm so sorry. Yeah, I'm ready when the polls are over. Just let me.
Yes, okay. So we'll give 2 4 minutes more.
Sure.
Those who have not entered the poll and given their feedback, please do that. Your feedback is really valuable. In last session, you have mentioned about we need a session on simulation, and we are delivering it now. So, we are really taking your feedback seriously. So make sure you are giving up your suggestions and feedback, and any more questions you have, you can definitely ask in the Q&A section as well. All right, let's go ahead. Devaditya, over to you now.
Yeah, thank you.
Yeah.
Okay, so yes. So all the results we asked for in the outputs, we have them ready here. So you'll automatically get a plots dialog box. So you could drop down here to either through all the options that are available. So let's start with velocity. So as I mentioned earlier, the drone is not actually moving. The fluid flow is moving relative to the drone. So of course, the drone will have a zero velocity. Then you can also scope for the velocity vector of the fluid flowing over the drone. You can compute the absolute gauge pressure as well. Now, if you want streamlines, streamlines flowing over the drone, for that, you can go to the action bar, select streamlines. You can define the refinement. So either from here, you can just click on plus. You'll see all the starting points have increased. Okay, you can actually see the streamline. So for a better view, I zoom in. Now, if you want advanced actions, you can change the appearance from line to even arrows. Click on apply to visualize. You can increase the speeds here. Let's say I'll go for 20. You can see a much more dense streamline that is flowing over the drone. And again, you can get much closer to the action if you configure the streamlines like so. Now let's see how you can do that. So I'll deactivate stream 7 here.
Now from this drop down, steering support, I'll select brake. Now you can see dialog. So an expansion of this box has come in. So here you can maybe put some value. So I already calculated them before. Take a very dense seeding of 50 and let's change the flow direction to down. All right. Now you can go ahead and select the starting and end point. So you will get the flow only over your places of interest. Now if you want only the wingtips, let's say, start and end point can be changed. Here for the start point, here for the end point, you can check for the wingtip vortices. Just back here. Now let's check what sensors we can use to scope different output requests that we requested earlier during pre-processing. So if I toggle to history, select force, I'll select vector component 1, which is basically through X axis. And from value per support, I'll select last. And for support, can now access the sensor. So the sensor says, so this is a vector basically, so minus 0.138 Newton was the drag force. And now you can scope for each and I'm sorry, that was not the drag force. So basically the force in X direction, not actually the drag force. So you can toggle around with different components and you can check the forces. like so. Yeah, so this is along the x-axis. So this will be the net drag force, that is around 328.5 newtons. And yes, that is about it, Shubham, from my side.
That was
All
very
right.
cool, Devaditya. So, there are a couple of questions.
Yeah.
Uh, the first one is from Abhijit. So he's asking, can we use 3D as a platform for multi-physics problem?
What kind of multi-physics problems?
So that I think Abhijit, you can post in the Q&A. Uh,
Yes.
yeah, by elaborating more. Until then, there is another one. Sir, please, is it possible to simulate the same model, but this time making the drone move with a particular velocity relative to the fluid motion?
You want the model to move?
Yes, I think
Okay,
he's
so
asking.
that will be computationally very expensive, and usually you don't do such analysis, with moving body parts. Otherwise, if you are using moving uh, models, then I think so better than Navier-Stokes, you should rather go for a lattice-Boltzmann based solver. You can move the mesh here for sure, but again, it will be computationally really expensive.
Great. So I think there are no more questions in the question Q&A section. If you have any questions, please post it in the Q&A section. Okay.
All right, that was such an informative session done by our both experts, Mr. Rahul and Mr. Devaditya. And to all the students, we will be coming with more informative sessions. And as I can see, more questions are coming. So Gunlik, you can take ahead.
So I think Abhijit have responded. So he's saying if what to simulate heat transfer problem through which evaporation process will be executed.
Evaporation, right? Yeah, we need to check. I think it is possible. The workflow, I will need to check. Drop a question in the community about what you want to simulate, and maybe we can discuss it in a Zoom conversation.
Okay, so there is another question from another attendee. Can you please show dynamic meshing like I want to prop CFD? Can you give me some insights for that?
Yes, I think there are courses on dynamic meshing. I will need to check if it's available with the student licenses. So yeah, let me get back to you again. Drop a question in the community.
Okay, so another question is it okay to use Flow Express and Simulation Express for the competition?
I think it's with SolidWorks, if I'm not
Y-
wrong.
yes, I think.
Yeah, then go
But
ahead on it.
so, so it again, so to use to do the simulation and anything regarding this competition, you already have all the tools. So Rahul has also uh, like shown you how to do the simulation in this solid simulation, and Debarita has told us about the simulation in the 3D experience platform. So you have all the tools, so you need to choose them. So please use the provided tools only from us.
And those who are looking to install simulation software, I'm dropping a link. You can refer that link It's a detailed how you can install. So basically, you have to install any particular application which is available to you. So in simulation, you can find structural model creation, I guess the name of the app, and or you can select any simulation app and you just install, and after that, whatever app you want to open, you can launch it and then you can utilize it. What Devaditya has shown in his demo.
Mm, Yes, so there is question, did anything was discussed about ModSim? I think so the recording of the session will be posted on the community. If you have missed anything, you can refer the recording at any time as per your convenience. So it will be soon posted on the community in the same post where all the recordings are available.
Yes. All
Okay,
right,
okay.
and to the teams, is there any more question?
There is
Okay.
the last one for
Uh,
the FTC submission. If we submit our FEI using NSYS, will we be penalized because one of the team member is expert in this software? So again, I would like to emphasize that all the tools for to explain your project have already been shared to you, and you have all the accesses. And we are also arranging the educational webinars regarding that. So please refer those webinars and use the tools shared in the competition only.
Yes. See, basically, you are participating in a competition being organized by Dassault Systems. And Dassault System has its own set of tools, which we are encouraging all the teams who are participating to utilize it so that you can enhance your skills, enhance your expertise in those particular tools. So therefore, the submissions in which we find that you are utilizing any third-party tools or any apps, even if you are putting a screenshot, we'll definitely figure it out that you are utilizing some other applications. Those submissions, those teams will be disqualified immediately. So make sure that if you are planning to use such simulations or utilizing simulations for your design, make sure you're utilizing our solutions. And why not? See, we are always available for you. You can ask as many questions as you can in the community. The only thing that is lacking is your hesitation to ask us. I feel if you remove that hesitation from your mind and you ask questions, definitely our experts will be there to support you with that.
Yes, also to add another perspective that you have all the tools, and like you can do the rendering on the same platform, you can do simulation on the same platform, you can do designing too on the same platform. So why to go anywhere else, right? So please utilize that platform and do all the things on the single, like you don't need to export anything, you don't need to like go anywhere else to install anything else. So why not to use that, right? So please make get benefit of that and go ahead with your submissions, and best of luck.
All right. And now we have hardly 3 weeks more for the final design submission. So I recommend all the teams who have not progressed so far after IDC, or those who have not submitted your IDCs, kindly complete your IDCs and FDCs on time. We have now kept a single deadline for all the tasks because earlier we have given different timelines for all the tasks as a steps one by one, but we have seen many of the teams were not able to complete it on time and they were looking for the extension. Hence, we have kept one deadline only for all the tasks that is important to submit, which is IDC, FDC, and selfie with mentor. So all these three tasks should be completed by 15th of September. Kindly make a note of this particular deadline. This deadline will not get extended further, not even a single day, because we are already delayed and we have to announce our further shortlisted teams who will be qualifying for further rounds, and we will be arranging the country level finales for respective countries starting from the month of October. This is just a kind information for all the Egyptian students, Egyptian teams, that your finale date has already been fixed. It will be in the first week of October. So by 15th, we will receive the submissions and we will try to announce the results of Egypt country first and later for other countries. And once the details have been announced, the teams have been announced, all these teams will be communicated further to join for the Egypt finale event. Let me remind you, this information is only for the Egypt finale teams who are going to compete further. So make sure that whatever design, whatever submissions that you are doing a very good and thorough submission so that you get fair chances to get shortlisted further by our evaluation team. And more information, more updates will be sent to you, to all the Egyptian teams separately regarding the finale. Similarly to other country teams, their country finales or geo finales will be arranged separately. We have not received the dates so far from the partners. Once that is fixed, we will also send you a common update as we will get the information. So it's just a kind reminder to all of you. Please focus on it. Now is the last 3 weeks for you to complete your submissions and do everything with your dedication. Ask many questions as you can. If you need any kind of support, you want us to get on a call, just let us know. Asking a question in the community, don't ask a question in personal conversations. You can ask all the questions, any kind of question, so that others can also see that, yes, this is the kind of question I also wanted to ask, but hey, you have asked it. So let me check the answer only. So keep an eye on those questions, and we will also keep an eye on your questions. If you need our kind support, we'll definitely connect, and we'll definitely connect you with the right expert and mentorship as well, as we do and promise each and every single year. So with that note, I wish you all the very best to all the teams, and stay connected. Those who are still asking questions after this, please ask your questions in the community. Drop us an email. We will definitely respond you back. All right. Thank you so much, Debaditya. Thank you so much, Rahul, for giving your invaluable time on this weekend. And thank you for Kunlik for joining again. And looking forward to connect with you and all the teams tomorrow onwards as well. Thank you so much and all the very best. Happy weekend. Bye bye.
All the
Thank
best,
you,
everyone.
everyone.
All
Have
the
a good day.
best, everyone.
Yeah.
Bye bye.